I begin by praising Allah, the most beneficent and the most merciful. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Amma Allahumma iftah alaina nikmataka wa anshur alaina min khaza'ini rahmatika ya arhamar rahimin. Assalamualaikum warahmatullahi taala wabarakatuh, and a very good afternoon.
Waalaikumsalam, Doktor.
Ya, Alhamdulillah. Pada hari yang hujan renyah-renyah di Terengganu ni, insyaAllah kita akan dapat sambung semula perbincangan kita STM 3118 kita ni. Dan semalam saya ada dapat satu komen yang bukan satu, lebih daripada dua komen yang minta saya bercakap dalam bahasa Melayu ataupun memberikan penjelasan, penerangan banyak dalam bahasa Melayu. Memang semua mengidamkan macam tu ke? Atau tak ada masalah?
Dua-dua boleh, Doktor. Tak ada masalah.
Tak ada masalah. Dia tak boleh, dua-dua tak boleh. Dia mesti ada prefer satu.
Kalau prefer not English, Doktor speak in English lah.
Okey. Jadi saya akan cuba kita majoriti kuliah kita dalam bahasa Inggeris, tapi ada setengah penerangan yang saya akan cuba sampaikan dalam BM. Tapi boleh tak tolong saya tulis ke apa ke, kata perlukan penjelasan bahagian tu dalam BM. Kalau tidak, saya prefer untuk bahasa Inggeris sebab nota memang bahasa Inggeris. Saya belajar dia dalam bahasa Inggeris, saya baca buku dia dalam bahasa Inggeris. Okay? So let us continue. We have cover one big topic, okay, and then the first instrument that we have learned, especially yesterday, was the UV visible spectrophotometer. And today, insyaAllah, we will cover a new topic. Okay, our new instrument. The next instrument in line is the AAS, Atomic Absorption Spectrometry. Based on the name, it detects the atom. Compared to UV visible, it detects the molecule form of the element. Okay? That's one of the major differences. And again, this instrument also was built based on the Beer-Lambert law. Okay, it relies on the light. Okay, detection is based on light absorption. But here, light absorption is based on the atom. When an atom excites or it absorbs a certain photon, it will excite and it will show itself. So we can detect it in this case. Okay? Can we measure it? Can we measure the amount of that component inside it? Yes, we can. Okay, in this machine we still can detect and measure the concentration. How much is it? But remember, it's based on atom. So the metals or the elements or are based on this atomic presence. Okay, this is just a revision. We can see if it excites, means that it can be detected. If it doesn't excite, it doesn't do anything, it cannot be detected. And the principle of AAS is based on the first one. We can see the first one, each element absorbs and emits its own unique wavelength. Means that if we want to measure oxygen, we need to use a light source that is from oxygen. If we want to measure magnesium, we have to use the light source that is based on magnesium. Okay, same to other elements, magnesium, aluminium, what else? Sodium. The lamp or the light source itself has to be produced using that certain element, because it says here the first principle is each element absorbs and emit. When it absorbs, it can be detected. Emit means that the light source has to be from that certain element. Okay, and how the sample is being detected? The sample has to be vaporized. Dia mesti meruapkan. We introduce the sample to the machine in liquid form. But when it is in the machine, it will be transformed, not transformer. It will be, or it should be transformed from liquid to vapor using fire, using flame. Okay, that is the second principle. Vaporize. Okay, by aspiration means that by heating. Or it can also be evaporated using electric heated surface, furnace. It's just like we boil water, for example. When we boil water, the boiling water will produce gas, isn't it? It will vaporize. And if you leave it for a certain period of time, a longer period of time, there will be no water left. There will be just the kettle or just the pot. Okay, and the fourth or the third principle is at this condition, when it's vaporized, only the atom exists. Okay, so vaporized, only atom. So atom will be flying around, or in the form of aerosol inside a certain contained area. Okay, just like when we see smoke. Okay, you see, it looks like it's gas. No, it's actually in the smoke we have some solid particles that flying about inside it. Okay, when we spray the aerosol, isn't it? We spray aerosol. Inside the aerosol itself, it means suspended solid in the gas. Okay, aerosol. The simplest example, another simpler example is powder, bedak. Okay, powder, the talc, and we spread it out, we can see all the particles in the air, isn't it? That is one of the example of aerosol. Okay, we have some solid components inside the gas. And this atom, the vaporized or the single atom, will absorb the certain light that has been produced by the same element of that atom itself, and it can be detected. So what is it to remember? The first three. Each element, the sample is vaporized and is in atom form. That is the basic principle that we should remember. Dengar, tiga. Yang pertama, elemen ini atau bahan-bahan, elemen apa bahasa Melayu? Bahan-bahan yang akan menyerap cahaya adalah datang daripada sumber bahan yang sama. Dengar tak suara saya? Ke saya jauh sangat? Dekat sangat mampu.
Ya, doktor. Dengar je.
Dengar je. Takut kalau jauh tak dengar. Okay. Next. Ini pun masih lagi dalam prinsipal dia. Benda yang sama, diulang sekali lagi je. Okay, dan yang last sekali dia kata cahaya yang paling banyak sekali atau yang paling kuat, the strongest spectral line will be chosen. Only one wavelength will be chosen. Okay, to be used in the detection. How can we choose? How can we select this wavelength? Okay, using a monochromator. That is the principle. And still, it's based on Beer-Lambert law. A is equal to E or epsilon CL. Okay, it's based on that. Saya tak I'm not trying to discuss what is Beer-Lambert law here.